So dimensional expression of a physical quantity is an expression and using the units of physical quantity to express physical quantity. So any quantity measured in terms of mass, any quantity which measures mass is expressed with a symbol capital A and having this bracket. So the units can be grams, then it can be milligrams, whatever. So we express using M because it is an expression need to express the unit of mass. Any expression, anything which is measured in terms of length is expressed in capital A. Similarly, for time we use capital T. So these three units, these three symbols, can express almost any physical quantity. Both the derived and the derived physical quantities. And all quantities are expressed using these three dimensions. So these dimensions tells us the relationship between the units. For example, speed is equal to distance over time, you know that. But the unit of speed is, tell me the unit of speed is meter per second. You know this one.
Kilometer per hour.
Of course, it's also. So, but any unit can be, any unit of length is expressed as meter is a unit of length, so we can express dimensionally by using L. So we have L over T capital T, right?
Yeah.
So the dimension of speed is another. So you can also express this as L. T is the denominator and as the power of 1. But if you bring it to the numerator side, it can be L times T minus 1. Is that clear? Because T is a denominator, 1 is 1 over x. If you express it,
Negative
x to the power of negative 1, right? So because T is over here as denominator, I can express it. What about if x 1 over x squared is equal to 1? X to the power of
1.
1 over x squared can be expressed as x to the power of minus 2. So that's why, because this is the power of 1, we know there is 1 here. So we can express speed as nt. So speed is related to these two dimensions, the length and time. So it tells us the relationship of length and time in expressing speed. So this is how I can express the dimension of speed. Okay. There are also quantities actually, dimensionless quantities, because their units cancel out. For example, mechanical advantage. What is mechanical advantage? Mechanical advantage is
Kinetic energy.
mechanical advantage can be the advantage of the simple machine is load over effort, right? But the unit of load is Newton and the unit of effort is Newton, because these two units are cancelled. We don't get any units here, so mechanical advantage is dimensionless quantity. It has no dimension. So it is simply numerical expression which tells us how much, times the power is multiplied or the force is multiplied, or how many times the speed is multiplied. It gives us some factor, not a unit. So mechanical advantage, velocity ratio, and such quantities are called dimensionless quantities. So the three fundamental quantities, the three fundamental units, the mass unit, the length unit, and time units are very important to express all other graph units. So now let me give you some example. No, let me give you another example. So this is example one. Let me add another example. What about area? Area is actually the distance times width, right? But the unit of area is, tell me the unit of area is? The unit of area, because we have similar units multiplied.
Meter square.
Meter square, centimeter square. So tell me one of the units.
Meter square.
Meter square, it's okay. Because meter, so the dimension of area can be expressed because meter is, the dimension of meter is expressed in length. All units of area, centimeter squared, meter squared, millimeter squared, they're all under a dimension. So area, because we have m squared, that means we can use n the power of 2, because we have 2 length units. It's simple. Or I can make it length times length, which is n squared. So expressing area in terms of its dimensions is called, becomes n to the power of 2. So 2, the power of 2 which is multiplying this length is called the dimension of the unit. We call it the dimension of the unit. The power to which we multiply the fundamental unit is called the dimension. So we can also do another example. In that case, maybe why don't we do the dimension of acceleration? So when you want to find out the dimension of any physical quantity, just find the units. What is the unit of acceleration? What is the unit of acceleration? Yes? Yeah, okay, so the motion of okay, I'm sorry. That's that. The acceleration unit, the unit of acceleration is meter per second squared. Acceleration tells us how fast is a body moves, or the rate of change of its speed. It's okay. Okay, so now rotation, please. So now, what's the dimension of m? M is meter, so the dimension is
Length.
n, so capital L over the dimension of second is t, so it becomes L over simple one. Simple. So the dimension of acceleration will be L t is, you can also write this way, or if you
T minus.
L t the power minus 2. Right? Force is equal to mass times acceleration. We know the dimension of acceleration, but the dimension of mass is already given to be capital N. Any units of mass can be expressed using capital A. So the dimension of force will be, the dimension of mass is capital N, acceleration
And
L
T minus 2.
minus 2. Or you can also use this one.
It's a magnitude.
Force. Force is expressed as mass times acceleration. You remember this one? So we simply use the dimension of mass as capital N the dimension of acceleration is already defined here. So you can express it this way, or if you are interested, m L over
T squared.
Can I have the first one? Is that simple? Simple. So, having said this, I have to give you some short notes. Because of materials and let's have short notes. But before that, let's and speed density. Speed density. Let's do dimension of density. Density, if you remember, the unit of density is
Mass over volume.
mass over volume. Density is mass. The formula is mass over volume. But we want the unit. The unit of mass is
capital N.
First, let's go to the limits, then we'll go back. The number one in the limits, then V is
Meter.
So the unit of density is kilogram per meter cube. Also gram per centimeter cube. We have also this option. Anyways, so the dimension of the mass unit kilogram is M because kilogram is mass, right? Kilogram is mass unit. So kilogram can be expressed using M. Is that clear?
Yes.
Clear. Okay, so we have M. We use also brackets over L cube because meter cube can be expressed by dimensions L. So it is L cube. Or you can express M L minus 3 because it's 3.
So now, when it's together, it doesn't need brackets.
Yeah, so I think this express marks altogether. Yes.
When it's real numbers, like you multiply them and then you get minus 3.
This minus 5 actually powers. So the exponential notation. So 1 over x squared can be expressed as x to the power of minus 2. The formula is 1 over a, the power of n can be expressed a to the power of minus a. I think this is mathematics. It's very simple. Classical positive corner or let's go to negative. Let's assume 1 over a is the power of minus a in the b1, a the power of positive a in b1. I'm sorry, 1 over x the power of minus 2b1 under b1 x. If it's negative, it's going up, it becomes positive. So that I think simple. Okay, so I think the formula, I can give you a class of units, you can change it to these dimensions. Let's go to materials, let's take some mass. First table, start from time. Just as a classroom, can try the dimension of power. Power is equal to work done over time. Work is equal to force times distance. Power is equal to force is mass times acceleration. Is so power. So use the mass, acceleration, distance, and time. So use the units first.
Mr.
Mass, acceleration, distance, and time. So immediately first change this one into its unit, then change it to dimension as a class.
Mr.
Yes.
안되면 double times 마를 붙이려면
That's if you have like 2 units similar, you can separate. Sorry, if you have L and L square multiply.
Okay, 안되면 it says MAS over time now.
Yeah, mass times acceleration over time. Yeah, acceleration unit.
Apply S into distance.
S is distance. Yeah.
Oh.
So first change this into its fundamental units. Then this units into the dimension. It's so interesting.
Mr.
Yes.
Lastly, we have the triangle statistic.
Which one?
The triangle speed.
It's okay, you can find this one. This is good. መጀመሪያ ቅድም ታሳያችሁ አክሰለሬሽን ምን ነው?
Acceleration.
የፎርስ ምን ነው? ማስ ታይምስ አክሰለሬሽን የማስ ዩኒት ማለት and acceleration, because acceleration is unit of acceleration is meter per second squared. The n one hundred L s is time
T minus
t squared L T. የፎርስ ካላችሁ
No, I don't think that's just give us the triangle average.
okay, yeah, distance is equal. Okay. Yes. The dimension. You know, acceleration, unit and dimension. Yeah, distance, simple because it's fundamental. And t, time. So put it and find the meaning. እዚህ ጋር ከፈለግ ሴፓሬት ለመስራት የማስን አክሰለሬሽን ከዛ
Okay, speed and ስለረሳሁት
እሺ ስፒድ is equal to distance is speed v ነው is distance over time ግን እዚህ ጋር ስፒድ አለ ወይ ይህ ዲስታንስ ነው ስፒድ አለ s is distance
so v so s is equals to vt.
Acceleration አላችሁ acceleration እዚህ ጋር ያላችሁ acceleration እና አንሰጣችሁ acceleration ያው acceleration እዚህ ጋር
m per second square.
ይሆናል
Example.
ግልጽ ነው? ብዙ ሰው እየጨረሰ ነው። ተማሪ ነው።
ሚስተር ኢሙ ማስ ማለት ነው።
I think I may need to give correction before I leave. Yes, class. I think time is over. Maybe give you a correction. Okay. When you have this kind of a little bit complex equation, a little bit, you need to express this in terms of, because power is work done over time. Power can also be expressed. Work done is force times displacement or distance over time. Force doesn't. So force is mass times acceleration. So we have this case, and we have time. So power. Now let's go back to the units. The units of the unit of mass and acceleration. So now let's express this as a dimension. Would you please stop writing? Stop. You're teaching. You're missing. At this point, now we can change the units into their corresponding dimensions. The unit of the dimension of mass is capital M. Acceleration is, because the unit of acceleration is meter per second squared, I can express it m over t squared, right? M times L over t squared times the dimension of distance. Distance is the length unit. Yeah, right? I can express this. So what's the dimension of it? L t squared. And we have this t. We have this t. So the dimension of time is. So then we put this one. L over t squared AC. We have the dimension of t is, again, capital T.
-2.
So the dimension of power becomes n, L times L is n squared over, because we have this one here, it becomes t the power of
Square.
so 1 plus 2 is 3. So the dimension of power becomes, if we bring this one up, n, don't forget bracket, L squared t n. This t cubed in the form?
T1 is
T is the power of
the power of
minus.
Mister, I don't think it's supposed to add. Okay. T, not t squared, it's just t squared.
T2 naman.
A power of x times the power of y becomes a the power of
X1.
x plus y. So this is the one. T the power of 1 times t the power of 2. 1 t the power of 1 plus 2, which is t the power of 3. Tito le maths exponential law. ለዛ ነው አፍቲ ያለው እዚህ ጋር የታይም ዲስ ታይም የአክሰለሬሽን ወደ ስራ በጣም ትንሽ ነው ነው ያለው this has 1, that's why when we add it 3, but when you bring it to as a numerator it becomes minus 3. Most of you have tried in most of you have done it. Yeah, hullaችሁ ከተስታ
Simplify our
for the expression if you are in